Okay, can we go?
Yes.
Great. Good afternoon, ladies and gentlemen. Today, it's my great pleasure to host a talk with my old friend and one time a student, Mike Shipulski. Let me first read for you his official bio, and then I will add a couple of words of my own. Mike has earned his bachelor's, master's, and doctorate in engineering at Worcester Polytechnic Institute in Worcester, Massachusetts, which is located about 1 hour west of Boston. After his undergraduate degree, Mike worked at General Electric Aircraft Engineers. He went back to university, and after his master's and PhD, he worked as a manufacturing scientist at General Electric's corporate research and development when General Electric was just starting its Six Sigma initiative. Mike was first exposed to TRIZ in the early 1990s and continued to study TRIZ on his own until his intensive TRIZ training program with Victor Fay, which is yours truly, where he earned certification as a TRIZ practitioner. Mike has used TRIZ to solve challenging customer and business problems, which have helped Hypertherm. Hypertherm is the company he's been working for. It's the top manufacturer, if not the best manufacturer of plasma tools and machine tools for plasma technology. So he helped Hypertherm grow its profits and revenues. Mike has also used TRIZ to create new technologies, for example, consumable recognition technology, to solve customer problems that they didn't recognize as problems until they saw the solutions. Mike is a certified TRIZ practitioner with about 40 plus patents. To his credits, Mike developed the world's most successful plasma arc cutting system. He is a contributor of the year for design for manufacturing assembly, DFMA. He writes a blog post every Wednesday religiously. I can attest to that, for over 14 years, which now total to 700 plus blog posts. He has his own website. And Mike has been a top innovation blogger for the last 10 years. It's a very tough competition. There are many people who want to be, who write about innovation in the world, and to be one of the top consistently for 10 years, it's quite an accomplishment. Well, it was an official bio of Mike. Now let me add just very quickly a couple of words of my own. I have taught hundreds of people in across different countries, and Mike is one of the 3 top of my former students. When I first met him, it was about 15 years ago. I thought that this guy has to be the face of TRIZ in the United States. Young, smart, handsome, energetic, a man of few words but many deeds, sharp. So I still hope, Mike, for you to be a representative of TRIZ, at least in North America one day. So Mike, the floor is yours, or the screen is yours.
Thank you, Victor. That's very kind. So what I would like to do is describe some of my background and how it prepared me to be appreciative and ready for TRIZ, and then tell some stories about how I've used it and some of the challenges around TRIZ organizationally, then we can have some discussion. So also, if you want to ask some questions, signal to me, and I'll stop. So firstly, I'll speak to my first professional job after my bachelor's degree was with General Electric, GE, and aircraft engines. And what I learned to get me ready for TRIZ was that design is broad, and we had to take great pains to assemble, build the engines, and test the engines in the factory to make sure that they worked. And I learned about the tight and important relationship between design, meaning what the aircraft engine will do, and the manufacturing process, how to build it. And that breadth of design and engineering, design and manufacturing together really set the stage for a broad perspective of design and get me ready for using TRIZ in a broad way.
Yeah, edit video juga sila. That one.
And as my master's and PhD, one of the themes of that work was based on axiomatic design. Nam Su from MIT was a three-space design theory: functional requirements, what the product must do; design parameters, what are the elements of the design itself responsible for function; and process variables, what in the manufacturing floor must you control to make the design look the way it does, such that it functions the way it does. And this was extremely helpful in a way to define systems broadly. So it's not just what the physical design looks like, but it's what it does and also how to make it. And I really credit my understanding of that broad axiom, three-space design theory is really setting the stage for TRIZ, because TRIZ is such a holistic, takes a holistic view of problems and conflicts. The other area of interest that set me up for TRIZ was the idea of functional coupling in axiomatic design. The classic example is if you have a water faucet with two handles, one for adjust the hot water and another for the cold. If there are two functional requirements, like you must get the temperature correct and you must get the flow correct, they're coupled, meaning if you make the water warmer, you increase the flow rate. And so that concept of functional coupling allowed me to appreciate, when I saw the TRIZ principles and the TRIZ mechanisms and tools to cut through, to break that coupling. So that was really helpful. Another thing I learned in my first official exposure to TRIZ was in 1990, while at university. There were two TRIZ experts came to visit and make a presentation to the professors in the program. And while I thought their presentation was intriguing and interesting, the experts in the university did not receive well the TRIZ presentation, and it was somewhat dismissed after the fact. And I could not understand why in the moment, but after reflecting on it, what I realized was that it was very novel. It was different. It was new language, and it was a different way to go about work. And it was really dismissed by the experts, and that stuck with me. And you know, that kind of colored how I went about things down the road. So, and that was in 1990. After I earned my PhD, I worked at the GE, General Electric's Research and Development, just at the time the start of Six Sigma. This was a long time ago, and there was an extreme focus on Six Sigma, and almost everything had to be done that way. And while the Six Sigma work was powerful in terms of reducing manufacturing variation or variation on the production floor, it really colored the entire company and really focused on efforts to reduce variation at the expense of maybe more innovative ideas. So what I learned was that you have to be careful to localize Six Sigma onto the manufacturing floor and reduce variation, but somehow separate and preserve the idea of creating novel solutions and protect the thinking about new concepts. So that was a very powerful lesson for me. Said more strongly and more plainly, Six Sigma done poorly or done too strongly can actually block TRIZ and block innovation thinking. That may not be shared by everyone, that position, but that has been my experience. I then moved to a startup company that was in powder metallurgy, where it was pressing metal powders into parts without sintering. And the startup funding was secured with a technical approach. And what I learned was that no matter how much I wanted to change or innovate and solve problems, I could not deviate from the technical approach that was used to secure the funding. And in a situation like that, there's no real space for TRIZ. There's no real space for solving new problems in new ways, which is really one of the extreme benefits of TRIZ. It helps you see problems and conflicts differently, such that you can solve them differently. But there was immense inertia around changing the technical approach. Then I moved to Hypertherm. I've been there for about almost 25 years now. And while doing some work on new product development with a gentleman named Don Clausing, he introduced me to his co-author, Victor Fay. And here's the book that I learned about, Effective Innovation. This is Dr. Clausing and Victor's first book. And that was my entree into official TRIZ training. I was fortunate enough to create a very special one-on-one training program. I don't know how we managed to do this, Victor, but and Victor would fly to me, and we would do 1 or 2 days, was it a month or so, and then I would do some problems in his book, Innovation on Demand, and here's the other one. So just to be clear, I do have both the books and keep them with me. And I received a deep training in TRIZ, and almost immediately within a couple months, I started to see problems differently. One, I saw problems where I did not see them before. And I had a set of tools to help me systematically formulate problems in new ways. And then what I've learned is that formulating them in those very defined ways was almost solving. And the formulation was solving, not quite, but seeing the problems differently and more deeply was just a huge benefit to me, and it really opened my eyes up to what could be. After my initial training, I was so excited about TRIZ and how the company could use it to solve new problems in new ways. I invited Victor Fay to present for maybe 3 or 4 hours to our management team, and I think they were polite and appreciative. And from there, I thought I had enough buy-in or emotional support from the management team to try TRIZ at the company level. So I organized, I think, a 3-day session with Victor to come and present to 25 or so of our top engineers. And And I thought that it was going to be great. I thought that everyone would just love it like I did, and it was so powerful. And what I learned was that Hypertherm was a very successful and has been a very successful and profitable company, and the engineers were very successful and had a high status at the company. And what I learned was that they did not appreciate, as I did, the value and the power of spending the time to define, formulate problems in ways to help them see things differently. And Victor, maybe you can speak about this later, or what you thought of the response, but I wasn't pleased. And TRIZ never really took off within the company from that 3-day session. I just was really, I was stunned with the reaction. It wasn't, they weren't overtly negative about it, but they didn't really adopt it. And I think they found it, spending the time up front to formulate the problem and understand it as a waste of time, where they think they already had the solution. So TRIZ didn't really move throughout the company as I had hoped with that 3-day session. So I think it went dormant a little bit, and I changed my approach. And Victor spoke about this in his previous presentation to this group, where what I tried to do was to use TRIZ to solve difficult problems. The idea is, if I could help the company see what TRIZ can do by solving important problems, whether they be problems to fix things that couldn't be fixed, or create new things that couldn't be created. And I'll tell one story. As we grew in our factory, our cutting labs grew, and there were more and more of them, and they produced, they were water-cooled cutting tables. And so as we added more and more cutting labs, the heat load for cooling the water increased beyond our ability to cool the water. And it was so significant that we actually could not put any more cut labs in. We could not grow. And somebody proposed the appropriate solution of a large cooling stack, a cooling tower to cool the water. But the CEO said that was too expensive, and we had to do it a different way. And we were blocked from kind of growing. And so I used TRIZ to do an exhaustive study of based on the physics of the cooling, and created 4 or 5 solutions. And the work was so physics based and sound and complete, because of the process followed by TRIZ, that he ended up approving the spending required for the cooling tower, because he realized, that it was the TRIZ work was so thorough. He said this is the only way, so he approved it. It doesn't sound like a big success from a commercial standpoint, but it really did unblock our growth in terms of our ability to design new products. And in the background, I tried to continue to solve difficult problems, and maybe 2 or 3 engineers really gravitated toward it and used the methods and had good success. But it wasn't until the founder CEO retired that the new CEO went to a cutting show in China and learned that there was a strong and ever stronger competition of local Chinese companies that were making aftermarket consumables for our products. And the consumables in plasma cutting, they're basically copper pieces at the end of the torch that wear out. And there was stronger competitors in China that were making aftermarket consumables and the revenues numbers were dropping for us. So he said, how might you create new value for our customers that make it advantageous or protect the consumable revenue? So meaning if the aftermarket companies could not use our best technology, then the end users would actually use our consumables, and we would retain the business. While he did not know the ins and outs or the specifics of TRIZ, he did know that I had demonstrated some novel concepts in the past using TRIZ. So I ended up taking about 6 months and coming up with novel solutions that actually solve the problem. And one of the strong elements of TRIZ I keep coming to is problem formulation. One of the mantras that I developed was TRIZ helps you move from a telescopic view of the problem to a microscopic view. So moving from telescope to microscope. And I challenged myself and the people that I work with to draw a picture, a cartoon of the problem between two things. Where in the design is the problem? And that's a strong tenet of some of the principles of TRIZ. Where is the problem between what two things, and when does it happen? And so those two focus areas I found very helpful. And as it turned out, through the TRIZ analysis, I learned that there was a simple lack of information passing from the consumables to the torch and then the power supply. And what I created was an RFID tag on the consumable to pass information from the consumable to the power supply. And what that allowed us to do was to have the consumable itself configure the power supply. And what that eliminated was a massive problem of missetting the power supply for the consumables. Each set of consumables would need to be set up correctly on the machine, whether it's gas flow and timing and all that sort of stuff. So we eliminated a significant problem for our customers. We added an RFID tag, filed patents, and 10 years later, we ended up commercializing it. And that's another part of the learning from TRIZ, is that the concepts that are created are novel. And truly novel concepts can take some time to be assimilated by the organization. In this case, it took about 10 years from first prototype testing to commercialization. Now, TRIZ is not responsible for the length of that time, and certainly there are some cultural issues or cultural norms that have to be that are responsible for that. But TRIZ was really the catalyst to create these novel solutions. Let's see. Let's see. So what one of the most powerful elements that I found from using TRIZ is, and I said it before, is really focusing on what the problem is. And I have found that, at least for me, at first, the first time I tried to solve problems this way, it was very difficult in that when you build to, like, say, a model of the whole system and trying to find the problem, I could never really get to distilling it down to the essence of the problem. And the TRIZ process for me has been really helpful in doing that. And what I found is that if you can show people, walk them through with the help of a good teacher, frankly, how to come to the essence of these problems, that is a really good way for them to understand the power. And let me step back, I forgot to mention, I showed you two books by Victor, and if I had tried to do TRIZ without Victor's help and read the books, and I'm really good at reading books and understanding concepts, I don't think I would have been nearly as effective. To me, with my TRIZ training, it took 6 months or so of dedicated training and real hard work over the next 6 months to learn, and then to use the tools to solve problems. So to me, it's more like learning a new language. You can speak, basic things within a couple of weeks, but really to be conversational and to know when to use the right elements, I think it takes a course of study and a really good teacher like I had with Victor. So I hope that message comes through. Let me see there. Now I want to talk about TRIZ and patents. So in my work at Hypertherm, I was responsible for the patents at the company, and what I have found is this problem formulation and then tight solution based on that problem are very helpful in defining the novel elements of the work and translate directly into good patent claims. So after you're done with the TRIZ work, you have a recipe of or a knowledge of the limitations of the existing system and how the new system is better. That makes it easier and clearer in the patent application. So you can know what the novel element is, and you can actually even describe which problem or conflict you're trying to solve or break. So with regard to patents, there's a huge, very tight linkage between TRIZ and filing and creating new patents. And I want to tell you just an example I have found that TRIZ helps me think differently. And just last week, we were working on a new sensor, and the sensor had to deliver some abrasive and actually measure the abrasive. And we were having difficulty with variation in the sensor, and the delivery mechanism to the sensor and out of the sensor had to be flexible to deliver the media, in this case abrasive for water jet cutting. But that flexibility within the sensor itself was causing variability, meaning it was not repeatable. So it was without any kind of TRIZ formality, but it came to me that the tube that delivered the abrasive to the sensor had to be flexible where it was being delivered and exiting the sensor, but it had to be stiff where the sensor was doing the measuring. And in that fundamental of flexible in one area and stiff in the other is a separation in space, and it solved the problem. The whole tube to deliver the abrasive couldn't be stiff and glass-like because it would break, and within the sensor it couldn't be flexible because it created variation. So I looked at the problem after maybe a decade or 15 years with TRIZ, and it came clear to me: make it flexible where it needs to be flexible, and stiff where it needs to be stiff. And that's a little anecdote of a problem-solving session that didn't require a formal TRIZ problem-solving effort, but TRIZ really influenced me such that I could see things differently, and that solution came to me, I don't know from where, but it came. So over the years, TRIZ will change you and make you a much better problem seer, solver, and it's done so with me. I want to finish now a little bit with something, some closing thoughts. What I have found for me is that TRIZ offers a different way to think about problem solving, and to me, it didn't come easily or quickly. You have to work for it, but it's worth the effort. But what I have found, it's very important to understand, or was understand for me, was why was I interested in TRIZ? Why am I putting effort into this way to think, way to work, way to be? And what I realized is I wanted to make things better, make my company better, make the products I work with better. But I also wanted to make myself better and to improve my ability to solve problems, elevate the caliber of work that I could do, and to improve myself. And for me, I needed that type of motivation, continued motivation to work through some of the challenges that I experienced and some of the inertia that I experienced. It has been difficult, but it's been effective and fun, and we've made huge progress in our company because of TRIZ. And let's see. All right, just let me close now. I have found TRIZ to be powerful. It's powerful sometimes in that it can threaten, but even more powerful in that it can help you reinvent and just create things you didn't think were possible. It has for me. So important element for me was to link or connect the TRIZ methodology, tools, processes, and thinking to important problems, important business objectives. If you have the goal of the company to improve profitability, use TRIZ to solve problems that improve profitability. If you have a company initiative to grow into new markets, use TRIZ to create the new concepts that fit the new customers better and solve new problems for them. So TRIZ I see as a methodology and approach to do your business better, to help you achieve your business objectives. And I have found the closer that I linked TRIZ and the way of working to solving important problems for the company, the more appreciative people are of that work, and the more people would like to do it. Let's see. I saw some questions. Let me just finish, and then we can take them. And lastly, with TRIZ, be patient. Be patient with yourself because it's new learning and it can take some time. Be patient with people around you because it's different. And be patient with your company because it takes some time, but don't be too patient. Have a sense of wanting things to be different. And I think, at least for me, I found TRIZ as an effective way to help make a difference in the world. So those are my prepared remarks, and I'm happy to address some questions.
Mike, thank you so much for your super interesting talk. Every time, Mike, I know you think about TRIZ, but every time I hear Mike talk about TRIZ, I learn something about it myself. So thanks so much, Mike. Now, there are a few questions. Some of them are made public, some of them, for some reason, addressed to me. So the first question is from Manik Sood. Six Sigma use the DMAIC cycle. What cycle does TRIZ follow? Is there a cycle?
Well, there is a cycle, and you taught me the TRIZ cycle, and
Guilty as charged.
I'm sorry.
Guilty as charged.
Guilty as charged. Yeah. So there is a cycle, and the one you taught me, Victor, was called TRIZ. And like DMAIC or DMAIC, it does have multiple elements, starting with understanding the system as it is, and then moving to what type of conflict you might have, and then it gets into some of the ways in which you can, once you've characterized the problem, there are suggested ways to solve it. So yes, there is an analog to the DMAIC of Six Sigma in TRIZ. I didn't want to get into the depths of that in this talk, but maybe there could be some more or a special event around that approach.
Thank you, Mike. Next question. Again, from Monique Sood. How much TRIZ is useful for service industry? It originated from the manufacturing industry. Is it applicable for service industries such as call centers, BPOs, KPOs? Have no idea what they are, etc.
Yeah, I've used TRIZ outside of the manufacturing floor, certainly, and yes, it is. And I see TRIZ as a way to assess all types of systems, technological systems, and even with people systems. Those are more difficult. But yes, you can understand fundamental conflicts in a service organization or in a service approach. Where isn't information flowing, or where is it insufficient? That would be one likely area of discovery, I think, or what you might find. But yes, you can abstract TRIZ into different types of systems, including the service that you described. Absolutely.
Thank you, Mike. Now, next question is from Horst Naller. Nice to see you, Horst. How could TRIZ be disseminated better in light of the effort needed to become fluent in TRIZ versus the wish to get fast results? Will it always be an expert system for some chosen few?
Well, I think that there are multiple levels. I think there should be and will be a set of selected few that are TRIZ masters, like Victor Fay, and there will be some TRIZ practitioners like Mike Shipulski that don't have all of that knowledge, but have enough to be more than dangerous. To really solve problems with these analytical methods. And I think there will be some on the production floor where there are some TRIZ basics, like separate in time, separate in space, draw the problem between two things, zoom in, that can be broadly applied. So I think there should be a mix at various parts of the company. So I think it can be broad, but not everyone can be a TRIZ master, I think.
And does have to be, and not everyone doesn't have to be a TRIZ master. Now, a question from Suresh. Hi, Suresh. TRIZ many times conflicts with other techniques like design thinking, Six Sigma, etc. How do you deal with it?
Okay. Well, I think Six Sigma is best used on the manufacturing or in the factory floor to reduce variation. I think lean manufacturing is best used on the manufacturing floor to eliminate waste. And keeping a knowledge of where those tools are best applied is very helpful, but can be misused in areas where they don't best apply. I have found that design thinking is maybe strong on theory and at a high level in approach, but I found it lacking in terms of tools to actually facilitate problem solving and creative solutions. My guidance would be try to use the right frameworks and tools for which they were intended. And if I've tried design thinking and converging and diverging and all that, but what I found with TRIZ is it's really it gave me ways to do that kind of work.
Okay, thank you, Mike. Now I have some other questions, which are just sent privately. What are some common misconceptions about TRIZ?
Well, I can give you one common misconception that I made was I thought that everyone would appreciate it as soon as they saw it, like I did. And that's not the case. Misconceptions, I would say if you're unfamiliar, that people didn't really believe that it was as useful and helpful as I have found it. A general misconception that I have experienced is that, at a successful company, there are good engineers that made good things. And I think they believed that that was the highest level of kind of problem solving, creativity that was possible. And were reluctant to consider new ways to do things. So that's one of the preconceptions. I have not experienced this, but there may be a preconception that you can read the book and do TRIZ right away. I don't know, Victor. You may have a better perspective on that side. I can only speak to what I've learned or experienced.
Yeah, sometimes people expect learning, especially in the corporate environment, learning new things within 2 or 3 days. Which is not the case with TRIZ. As you said, TRIZ is it's not quantum mechanics. It doesn't require you to take a 5-year university course to be proficient and then go into a PhD program to really understand it, and then into postdoc to find out that you don't understand it. No, it's much simpler, but still it requires quite a lot of personal efforts, and you can read all the books available in TRIZ, you can read all the articles, but until and unless you solve yourself several of your problems, which everybody else has considered impossible to solve, or very tough problems, you're not going to get appreciation for TRIZ, first of all yourself, and then make others believe in TRIZ. Now, there is another question. In spite of having a huge innovation strength, TRIZ has been very successfully used at Samsung, Hyundai, Siemens, Intel, and many other top companies. Why is TRIZ still not much known methodology, in your view?
Well, I can speak to my experience, and Victor, I'd like you to follow. You have more broad experience than I do. At least in my experience, TRIZ has been viewed as foreign, as a different set of languages, unfamiliar. Frankly, sometimes it was a Russian solution, right? To Russian, or what is this? I don't. Suffield. What the hell is a Suffield? I don't even. Or is it Suffield? I don't know. But it's part of its strength, right? Is that it's a different way, and that difference can be off-putting or unfamiliar, and geez, and why haven't I heard about this before? If it's so good, why haven't I heard about it? And here's something that's interesting. The people that are successful, like the companies that were mentioned, they don't necessarily want to share the success about this, right? It's like, well, TRIZ has a competitive advantage, but from my perspective, it's just different. And that was what, that's why I found it was not readily received. Victor, what do you think?
Well, yeah, I agree with all the reasons you just listed, but I would put the blame primarily on the TRIZ community. We haven't done a really good job in marketing TRIZ. Again, although TRIZ has been around for about over 2 decades, as the person who asked this question mentioned, it's been a huge success at Samsung, Hyundai, and many other major companies. We haven't done, we meaning the TRIZ community, international TRIZ community, haven't done really a good job in spreading the word about TRIZ to the general public, if you will. But it's a separate discussion. So let's move on to some other questions. Question from Vinod S. TRIZ is only useful when there is a contradiction, but in real world, always there are no contradictions available. So how TRIZ can be used in those conditions?
Well, I don't think you need a full-fledged 100% contradiction. I think you can have an insufficient function that can be improved by TRIZ, and that's not necessarily a contradiction in yes, no sense, but you can use TRIZ to improve a function, and that's, I don't think, an official contradiction. I think that looking for contradictions, and once you see them, you can solve them, and the reward is can be staggering.
I would like to add, thank you, Mike, but I would like to add something to that.
Good.
There are situations where we face contradictions or conflicts, and they seem to be apparent when you like the contradiction which Mike described in his speech a few minutes ago about the sensor, which has to be both rigid and flexible. So sometimes these contradictions are indeed apparent, but in many cases, what you perceive as a no conflict situation, but the situation or scenario which still requires an innovative solution, does indeed contain a contradiction, but you need to dig deeper into this problem, into this challenge to identify and formulate it. So you use special tools of TRIZ, which allow you, for example, function, modeling, cause effect, chain analysis, and some others, which allow you to see a conflict, sometimes a few conflicts or contradictions, although on the surface, there is no contradiction, there is no conflict. Contradiction is a fundamental property of any change. If you want to change something, not a little bit, but conspicuously, you change something else, because everything is a system. If you change one part of the system, again, I'm talking about a noticeable change. You try to improve something noticeably, not just a little bit. Then, by the very nature of the system, by the systemic nature of everything, you change something else. And in the prevailing majority of cases, this something else is a negative. So you have a contradiction. Whether you start with it or you drill down into it after having performed a thorough analysis, but in the prevailing majority of cases, there are contradictions. Now, another question. What do you think about the application of artificial intelligence to TRIZ tools? So how, in your view, artificial intelligence can cooperate or collaborate with TRIZ and vice versa?
Well, firstly, don't think we have artificial intelligence. I think we have machine learning solutions. And I think that the caliber and the knowledge, or the caliber of the machine learning algorithms are solely a function of the training data sets. And so I would say, where do the training data sets come from? How are they loaded? How are they continually updated? That will govern, in my view, the capability of machine learning solutions for trees. One of the concerns I might have is that you lose the direct implication or the direct knowledge of how the solution came to be. And I have found that understanding the existing system, and then that is the fundamental to creating options or solutions for the new one. And I would like that. I found that people are very, very good at doing that, and I think likely better than say a machine learning algorithm in that situation.
Thank you. Next question. How can TRIZ be beneficial for personal growth?
Well, for me, I've become a more confident problem solver, innovator. Also, I have enjoyed my pursuit of trees. I have enjoyed learning. I have enjoyed doing work that I didn't think was possible that I could do. I've enjoyed teaching other people trees and helping them solve problems and them feeling good about it. So I've grown dramatically through trees.
Thank you, Mike. What are some misconceptions about trees?
Well, we spoke about that, I think already. One of them is you can, as you said, you can learn it in 3 days, and then you should be adding value immediately. That's probably an important one. I think that's probably another misconception is that it doesn't. There's no real value in it. It's just something else. It's not anything. Not a big deal. Those are two.
Okay. Another question. In what ways can TRIZ help you in building a better career?
Well, if you solve problems that were not able to be solved, and your company prospers, that's good for your career. If people come to you with their most difficult problems and ask for help, the rest of the company understands that you're an important person, and that's good for your career as well.
Do you see any benefits of incorporating TRIZ into school curricula or extracurricular programs?
Yes, I do. I think that anybody can learn it. It has to be at the right level. And I think, like I described some of my experiences in Lean and Six Sigma and axiomatic design, I think that early experience really made me more receptive and open to trees. And I think if it's introduced earlier and maybe at the right level, I think it would, people would be more familiar with it when it was time to really dig in and learn it deeply.
Thank you. Now, another question from Horst. Did or do you facilitate workshops with people not trained in trees, using trees hidden in the background? If so, what's your experience?
That's a good way, like a Trojan horse, right? To not use some of the TRIZ language, but do some of the TRIZ work. And yeah, I've used it around problem solving. I've used it around important problems. So it's not as good to have to cover over the TRIZ, but it can work. It can work, and you just I've used different language for some of the TRIZ tools and processes, and taken some of the official formality out of it, and that can be helpful.
Thank you. Next question: how can you manage the learning curve when trying to acquire new skills?
Try to solve important problems as fast as you can, and you'll learn. And the next time, the second problem, you'll be better at it, and the third, you'll be better at it, and keep going, and you never run out of problems.
Okay, thank you. As an individual, how can I sustain my interest in TRIZ within an organization?
Well, some of it has to be internal. You start by understanding why you want to do it. Why are you doing that? And sometimes the reason may not be good enough to be sustained, and sometimes it is. And but I like your question. I have found that understanding the internal reason for wanting to do TRIZ is an important thing. It has been for me.
Okay, thank you. And another question, I'm not sure, let me rephrase it. Despite success of using TRIZ within the given organization, why does the management still not support TRIZ?
Well, I think that part of it is my responsibility. I've stopped trying to create a company-wide TRIZ program, and I've chosen to solve difficult problems with TRIZ. And in a sense, I don't have the motivation or the energy to create that change at my company. And so I don't blame the management team now. It has been a lot of work, and after 15 years, at least I said, oh, I just want to solve really difficult problems, and that's what I chose. That's where I've chosen to focus my energy, and understanding what I want, and that's where I've gone with it.
Yeah, changing other people is not what I would do either. So, Mike, thanks so much for your excellent talk. I personally enjoyed it. I hope the others also did. We've almost at the end of our session. Thank you so much, and thank you everyone who attended this talk. Hopefully, I have learned a lot about many things, and hopefully everybody else did. I would like to invite Mike for some other in-depth discussion on specific topics later. So hopefully we'll see you around.
Okay.
Thanks so much, Mike. Thank you for your time.
Thank you, Victor. Thank you, everyone. Bye now.
Thank you, everyone. Thank you.